Hi, my name is Arturo Escamilla, and today we're going to review three types of physics problems: vertical launch, horizontal launch, and freefall. Let's get into it. Okay, on our first exercise, we will talk about vertical launch. A rock is tossed straight upward from 1.8 meters above ground level. Its speed is 10 meters per second. Question number 1. Maximum height above the ground. Question number 2. Rock speed at 5 meters above the ground. So first, let's write down our data. Y equals 1.8 meters. Our initial velocity 10 meters per second, and we know that gravity will have the units of meters per second since that's the units we're working, and it's going to be negative because it is vertical launch, so we were going against gravity, so negative 9.8 meters per second. The first question, maximum height, we will use this formula. The vertical distance, we can call it like that, it's the initial velocity times time plus 1/2 gravity times square. Since we don't have time, we will have to calculate it first using this formula. Final velocity minus initial velocity over gravity. So we substitute our values and we get that is 1.02 seconds. Now we can substitute here and we get we substitute every value: initial velocity, the time, gravity, and the time again. We will get that is 5.102 meters, and we're going to add the 1.8 meters from the beginning of the exercise, so we'll get 6.902 meters. After that, we will calculate the rock speed at 5 meters above the ground, so we will use this formula. It's final velocity square equals initial velocity square plus 2 times gravity times y. So we will substitute the initial velocity, gravity, remember that it's negative, and here it is a 3.2 y, because we have to subtract the original 1.8 meters from the 5 meters we are trying to get. That's why we use 3.2, so we make the substitution, the multiplications and everything, and we will get that the final velocity, or the velocity at 5 meters, is 6.105 meters per second. The next type of exercise will be free fall. You were having a picnic on a 50-meter high cliff and accidentally dropped your apple. First question, speed of the apple after 3 seconds of falling. Second question, height of the apple after 3 seconds of falling. So let's write down our data. First, we know that the initial velocity will be 0 because it is free fall. Then our y will be 50 meters since that's the height of the cliff. Then time, we'll get it from here, so 3 seconds. And our gravity, it's 9.8 meters per second square, and it's positive because it's free fall. We're going with the gravity. So the first thing we can get is the height, so we will use the next formula. Y equals initial velocity times time plus 1/2 of gravity and time square. Since the initial velocity is 0, we can forget about that part and only work with this. So we substitute our values. Y equals 1/2 times gravity, positive 9.8, times the time, which is 3, square. And we will get 44.1. But here, this 44.1 is the distance that the apple traveled. That is not our actual height. So we will have to subtract that from the height of the cliff, so 50 meters minus 44.1, and we get that the actual height of the apple at 3 seconds is 5.9 meters. After that, we can get the speed, and we will use this next formula. Final velocity square equals initial velocity square plus 2 times gravity times y. So again, because we don't have initial velocity, we can forget about that, and we will use 2 times gravity, 9.8, and y here we will use the 44.1. So we make this multiplication, then we get the square root, because here in the formula the final velocity is square, and we get that it is 29.4 meters per second. For our final exercise, we will see an horizontal launch problem. So Messi kicks a ball from the top of a 120 meters tall building with an initial speed of 44 meters per second and in a horizontal direction. Question number 1. How fast will the ball hit the ground? Question number 2. What is the reach or the distance of the ball? So let's again write down first our data. So y equals 120 meters. Initial velocity in x is 42 meters per second. Gravity will be 9.8 meters per second squared. This is positive because we will going down, because this is a two-dimensional problem, a two-dimensional motion problem. And then the initial velocity in y, which is 0, because there is nothing affecting it yet. So we can calculate the velocity in which the ball will hit the ground, and we will use the next formula. Final velocity equals the square root of the final velocity in x squared plus the final velocity in y squared. But we don't have final velocity in y, so we can get it with this formula. Final velocity in y squared equals 2 times gravity times y. So we substitute our values. 2 times gravity, 9.8, times y, which is 120. We will get 2,342 meters squared over second squared. We get the square root, and it is 48.49 meters per second. Now we can use the values here. So you may have a question, where does the final velocity next come? So the final velocity next is the same one as the initial velocity, since it will be a constant, there's nothing affecting it. So we will just write down 42 plus the 48.49 we just got, and get the square root, and the final velocity is 64.15 meters per second. Now, how do we get the reach? Well, the formula we will use is an isolation, and the final isolation is x, or reach, equals velocity in x times time. But we don't have the time, so we will have to get it using an isolation of this formula. And the isolation is time squared equals the square root of 2y over gravity. We substitute our values, so y is 120, gravity 9.8, we get the square root, and the time is 4.94 seconds. Now we can use the formula to get the reach. So x equals velocity in x, which was 42, here you can see it, times the time, which is got 4.94. We made this multiplication, and we get that the reach of the ball is 207.48 meters. And that's everything. Thank you very much. Bye bye.